We're going to talk about solving quadratic equations, but with a little plus, a little bit more complication. So let's start by taking a look at this one. You might be tempted to take the square root of both sides and think that k is going to be equal to 4. Okay, that is possible. Taking the square root is a little bit dangerous though, because you have to accommodate for both the positive and the negative root, so that actually the two solutions for this equation are 4, which is positive, or negative 4. Now, that seems kind of complicated. We've never taken the square root of both sides. So another way to approach this is let's get everything over to one side so we can set everything to 0. Now, let's factor this. We recognize this is a dots. Now that we have it factored, we're going to set each of these factors equal to 0, or I can just use my inverse technique and know that k is going to be equal to 4 or negative 4. So my solution set is 4 or negative 4. So as you can see, setting things equal to 0 and factoring it gives you all the solutions, both solutions in this case, that you need. So please beware, beware, and beware of taking the square root of both sides. It is possible, but with great power comes great responsibility. Now let's look at this situation. It's set equal to 0. I don't see a trinomial that I can factor, and I don't see a dots. So I have to look at this and think, can I factor this? And so yes, there is a common factor of k. Now, I do have two factors. I'm going to set this factor equal to 0. I'm going to set this factor equal to 0. So I have two solutions for this equation, 0 and negative 5. So always check, can you factor out a GCF? One thing to notice, it's interesting, we have a second degree binomial here, and we get two solutions. We have a second degree binomial here, and we got two solutions. It's not always the case, but often the degree is a hint to the number of solutions. Now let's look at this one. You might be tempted to take the square root of both sides, but then you're going to get like m equals 2 root m, and that's just not helpful. One thing for sure, do not divide both sides by a variable. Technically, by attack solving approaches, we have done that in the past. And you know what? I let it slide because we were young and reckless. Do not divide by a variable, because what if that variable is 0? Then you're dividing by 0, and that is bad. We'll entertain that in a moment. So what we want to do is we want to set everything equal to 0. Now I don't see a dots, I don't see a trinomial. I'll look for a GCF, so now I'm going to bring a GCF out. Okay, so I set this factor equal to 0. Don't forget about this one. And I set this factor equal to 0. So m could be 0 or 4. Now, just as an exploration, let's pretend we divided by a variable. And I'll show you what happens. You get m equals 4. That's great. That's wrong, because actually the solution is 0 and 4. So that's why you don't divide by a variable, because you lose a solution. And also because the fact that one of the solutions is 0, basically you just divide by 0, and that's bad. Now let's look at this problem. Okay, I'm just going to have to take this slow, multiply everything out, get it all to the side, and set it equal to 0. First I'm going to check, is my coefficient here positive? If it weren't, I would divide through by a negative, but it is, so that's cool. And is it in ax squared plus bx plus c form? which is my courtesy order of descending degree, and yes, it is. Okay, so now I'm going to have to employ the product sum technique to figure out how to get a product of 40. Remember, I multiply this times this, and my sum needs to be negative 14. So I'm going to use a negative 10 and a negative 4, because those add up to negative 14, and they multiply to 40. So now I rewrite my trinomial into a binomial by expanding this middle term. I expand it by writing it using these new numbers that I got. I still set it equal to 0. Now I'm going to pair these up, and I factor out each of them. I see this x minus 2. I'm hoping I'll get an x minus 2 over here. That would mean I'd have to take out a negative 4. I can do that. Okay, I can handle that. Still equal to 0. And so now I factor out my x minus 2, and I get 5x from here, and the minus 4. Okay, I'm not done. Notice I still have my equal to 0 all along here. Now I set each of these factors equal to 0. This one's easy. I just know x equals 2. This one I could do in my head, but I'd really rather not until I'm really good at these. So, whoops. So we'll get x equals 4/5. So my solution is 4/5 and 2. And yes, you should go back and check in the main equation to make sure that works. I'm not going to make you do that on this video.